Assalamualaikum and good morning everyone. This slide explains the theory of distillation, which is the main separation process used in this experiment. Distillation is a method used to separate the components of liquid mixture based on the difference in their boiling points, in other words, their volatility. When the mixture is heated, the component with the lower boiling point, which is the more volatile component, vaporizes first. The vapor then flow to the condenser where it is cool and component remains at the bottom of the column. The expression process is based on vapor liquid equilibrium or VLE at equilibrium. On the right side is typical distillation column. The feed enter the middle of the column. At the bottom, the reboiler supplies heat to generate vapor. The vapor rise through the column and reach the condenser. In this experiment, distillation is used to separate the ethanol water mixture, and the effectiveness of the separation will later be evaluated using refractive index measurement. Thank you. Next is the refractive index theory. The refractive index is a physical property that describes how light travels through a substance. When light passes from one medium to another, it bends due to a change in optical density. This phenomenon is called refraction. In this experiment, the refractive index is used to determine the concentration of the ethanol water mixture. First, we prepare standard solution with non-concentration and measure their refractive index to create a calibration curve. Then, the refractive index of the unknown distillate is measured and compared with the calibration curve to determine its concentration. The measurement is carried out using a refractometer which measure the critical angle of light passing through the sample and prism. Lastly, since the refractive index is affected by temperature and the wavelength of the light, this condition must be controlled to obtain accurate and reliable result. Next is the packed reactor column. A packed reactor column is widely used in the chemical industry because it is simple, reliable, and cost effective. It consists of a column filled with a packing material or catalyst particle. As the gas or liquid flow through the column, it separates over the surface of the packing, creating a large contact area between the faces. This improves mass transfer and increase the efficiency of separation or chemical reaction. Because of this advantage, packed reactor column are commonly used in catalytic reaction, absorption, stripping, and pollution control. In this experiment, the packing material provides better contact between the vapor and liquid, which improve the efficiency of this distillation process. Thank you.
In this experiment, our primary goal was to purify an acetone water mixture using the principle of simple distillation. We also aimed to evaluate how efficiently the PET column performed this separation. To keep the study focused, we used a specific feed ratio of 20% of acetone and 80% of water, running the process for exactly 1 hour while taking measurement every 5 minutes to track the system progress. Looking at the main component for our setup, it all begins at the boiler, which is heat the initial mixture to create vapor. That vapor rises into the packed reactor column. The packing material inside is crucial because it provides a massive surface area for the vapor and liquid to interact, makes the separation much more efficient. Once the vapor reaches at the top, it enters the condenser to be cooled back into the liquid. Finally, this purified acetone flow into the product collector where the measure is volume and take sample for reflective index testing.
So the following section talks about the methodologies of this study. The first step of the experiment is to prepare the calibration curve of refractive index toward composition of acetone. The graph will be later used to determine the composition of acetone inside the distillate product by comparing their refractive index to the graph. So firstly, the mixture with different composition of acetone will be prepared. The volume of each compound used is as shown in table. Then those mixture will be tested on their refractive index. Before using the refractometer, the plate was cleaned by the ionized water to remove impurities. Then, a few drops of sample will be dropped onto the plate and covered with the cover to isolate it from surrounding environment. Then, press the start button for the machine to take the reading. After finish the reading, the plate was cleaned again by using the deionized water. After finish, so inside the reboiler, the liquid will be evaporate and flow through the packing materials. So those volatile vapor will be sent into the condenser to condense down the vapor into liquid, and the liquid will be collected in the flask below the condenser. So the yield of liquid product in the flask indicate that the liquid extraction process is going on. So every 5 minutes, we are going to take the temperature of mixture, temperature of distillate, and volume of distillate. The volume of distillate could be collected by opening the valve below the flask and collect them into the measuring cylinder to see how many ml of distillate product was yielded within the 5 minutes period. The temperature of mixture and distillate product could be collected from the electronic thermometer at the apparatus. Those collected distillate product will be used to test its refractive index by using refractometer. So this step is crucial to know the composition of acetone in the distillate product.
So for the result part, for the table 4.2, our calibration data, we read it the volume of the acetone and also water for each data set. And the refractive index are measured using the refractometer. And then for the table 4.3, we measure the temperature of the mixture, temperature of the distillate, volume of the product distillation, and also the refractive index of the distillate. So for the calculation part, we need to calculate the mole percentage of the acetone and also for the calibration curve. So to calculate the mole percentage of the acetone, we need to calculate the mole of the acetone and also water first. So to calculate the mole of the acetone, we multiply the volume of the acetone with the density and divide by the molar mass, and we can gain the mole of acetone. For the water, using the same step. And then for the most percentage of the acetone, we use the mole of the acetone and divide by the overall mole. So for the figure at the left, there is the calibration curve of the acetone. And for the right side, there is the volume of the product distillate versus the time. As you can see, the volume of the distillate are decreasing with the increasing of the time.
So for this discussion part, as you can see for the mole fraction of acetone versus time, the graph show a increasing trend of the mole fraction of acetone versus the time. In theory, the mole fraction of acetone should be decreasing with the time. This might be because of the equilibrium of the system and might caused by the fluctuation of the reflux ratio and also of the cooling water. And for the temperature of the distillation versus the time, the temperature doesn't change too much because the heat capacity of the mixture doesn't change too much and the heat provided to the system are constant. So finally, this is a graph of the mole fraction of acetone versus the volume of the product distillate. So in theory, the mole fraction of the acetone will decreasing with the volume of the distillate. So this is because at the start of the process, the system has a high concentration of acetone. This lead a high concentration in the early distillate product. As the time goes on, the acetone in the system depletes meaning less acetone is available to evaporate and separate. So that's why the mole fraction of the acetone will decreasing with the volume of the distillate.
In conclusion, the primary objective to purify the mixture was achieved. Besides, the distillate temperature remained stable at around 57 to 58 degrees Celsius, which aligned with the boiling point of the acetones. This shows the effectiveness in selectivity vaporizing of the more volatile component. And the result indicated that a moderate efficiency in the separation process, where the mole fraction of acetone in the distillate was maintained at approximately zero point 0.3 throughout the experiment.